Good afternoon. My name is Chris Elam. I represent East Central region for GA Larson. Today's Zoom meeting will be on the Rheem, the Econet communicating zoning. So some of you may not have used it before. We have several dealers that use it quite often. So this is going to be kind of an in-depth crash course into the Econet zoning. So we'll get started here. We're going to cover what components, what equipment can be used, what specific components are used, and then how to set it up, and then also how to troubleshoot it. Okay. Okay. This kind of gives you an idea of the components, the thermostats here, the master stat, the substats, zone boards, different type of dampers that we can use. We're going to get into the equipment and components first. What equipment is compatible? The gas furnaces that are compatible is the R97V, the R98V, which is your modulating gas furnaces. We also have the two-stage 96V and the 80% two-stage variable, the 802V. Air handlers, we have one air handler that's compatible for the Econet zoning, and that is the RHMV ECM air handler. Air conditioners that are compatible, which is the Prestige models, which is the RA17, two-stage 17 SEER, and the RA20, which is the 20 SEER inverter AC unit. Heat pumps, we have the RP17, which is your three-stage heat pump inverter, and the RP20, which is your fully communicating complete inverter heat pump. Rheem has actually coordinated with EWC controls to design their zone boards and their dampers. So you will have to use the dedicated Rheem Econet EWC control board. So this is kind of a close-up picture of the zone board. So you have options for 3 zones on this board. I'll go over the different sections here. Over here to the left-hand side, you see the E1, E2, and R and C. That's going to be your Econet communication wires. Down here towards the bottom left, they're unused terminals. So this section here, the RR section, as well as the IAQ relay, those are currently unused. You do have two dip switches here. So depending on what you're doing, you kind of have to be aware of what you're setting up. If you're going to do a 2-zone system or even a 2-zone with a bypass, those switches will be off. Generally speaking, they're going to be in the off position if you're doing using one board and not 2. And if you do have to make changes, if you're doing a 2-zone system, if you make the changes, make sure you make the changes with the power off and then turn it back on so it'll accept it. Over here you have three zones. Zone 1, Zone 2, Zone 3. You have 3 connections here. Power open, common, and power closed. You cannot use 2-wire dampers with this system. It's a fully modulating zone system, so you have to use a power open and power closed 3-wire damper. And they do recommend that you use the EWC brand dampers. The heart of the system is going to be the Econet smart thermostat. The smart thermostat is going to serve as your primary control of the zone system, and it must be used as the Zone 1 thermostat. It will allow the users to configure equipment, zoning settings, operate, and monitor the system. It is important. The part number here is the RET-ST700SYS. This thermostat is what you have to use for the primary Zone 1 thermostat. This one right here looks identical to the Econet, but this is actually your zone control. Do not order separate Econets for each zone. If you do, they're going to basically battle for control of the system, and it will not operate correctly. So you have to have one Econet smart thermostat, then you have to have the zone stats. The zone stats will be used in zones 2 through 6. The zone control will display the zone temperature and allow the users to adjust set points, fan speed, schedule, or other settings for each individual zone. The part number on that is the RECTL 700ZON. And note, these controls do not have to be a home run back to the Econet zone panel. They can be daisy chained on the Econet communication bus. If we go back here, you'll see all you have is the one communication port. So each zone does not go back to the panel. This is one of the Econet zone damper motors. They're again made by EWC. You have your 3 terminals here: common, power open, power closed. And you do have a manual gear release. So if you push this button, you can push that and release the gear to adjust the damper. The Econet zone control is designed for use with the EWC. They have 35 steps in their zone damper motors. These motors are used on the URD, SID, and ND power open and power closed dampers. This is the round, which are what they call the URD. This is the EWC Ultrazone round, 24 volt, power open, power closed. It allows for full modulating to any position. These devices are wired directly back to the zone panel itself, with each zone being able to support up to 5 dampers per zone. This is the Econet slip-in damper, the SID. These dampers are for retrofit for the retrofit market where rigid ducting exists. They're 24 volt, power open, power closed. This is the Econet rectangular damper, the ND style dampers. They will come in many standard sizes. They are all 24 volt again, power open, power closed. And this is your leaving air supply sensors. Leaving air supply sensor is required when a bypass damper is utilized. We'll get into a little bit when a bypass damper is required. But if you're going to use a bypass damper of some sort, you have to use the leaving supply air sensors. The air handlers has a specific sensor, the RXHT-AO2 kit comes with return and supply sensors. Only the leaving supply air sensor is required. Gas furnace has its dedicated sensor, which is a 47-24-225-01. And then see the sensors I and O to determine the location of the air sensor. Get into some installation and wiring. Big one is zoning considerations. Consider the following. What is the system's minimum and maximum airflow requirement? That is imperative. see the reference section of your furnace heat pump, so you can determine what your minimum airflow requirement is, how many zone panels are needed. Can each zone independently support the system's minimum required airflow? That's really important. So if each zone can handle the minimum airflow, then you won't need a bypass damper. If you have one that is slightly lower than the minimum airflow, a bypass damper will be required. And another one is a transformer required? How many zone boards and dampers? And then is a leaving supplier sensor required? They do have what they call an intelligent bypass. When used, the bypass damper will be another motorized damper. It's not a spring-loaded or barometric damper. Bypass opens at system startup for 60 seconds to provide a soft start. And then highlighted here is do not attempt to use a barometric damper or the EWC smart bypass damper. You're basically going to use whatever size damper you need for your bypass, and your board will actually recognize that it's a bypass and it will throttle it accordingly. Installing the zone boards. So when you order the zone kit, you get this nice little cover here, clear cover, nice box to mount it in. And this is the REP NL 700 ZON board. It is best to carefully design your zones, group rooms that have similar usage, occupancy, and heat load. Different levels, stories should always be separate. For better energy savings, separate the areas that will be unoccupied at different times to allow setback as needed. And then for precision comfort, separate areas with different heat loss gain as well as different levels. Typically, unless you're starting from scratch, you're going to be stuck with what ductwork that you have, and you just try to separate it accordingly. Usually like a basement, main floor, upper floor. When you're installing the zone boards, location considerations, likely locations are on a nearby wall or convenient studs, or plywood can be installed to support the housing. Do avoid mounting the control on the return or supply duct. Do not mount directly to any equipment to avoid damage to these devices and or the board. And the zone panel may be installed in an unconditioned attic, basement, crawl space, follow national and local mechanical codes. Installing the board. So there again, the part number is the REPNL 700 ZON. The housing itself can accommodate 2 zone boards. If you do have to add 2 boards, so if you're doing 3 or more, you remove these screws. There's 4 screws on each side on the outer edges. Remove those, and then you can move your board up, reinstall the screws on all 4 corners, and then you can mount your new board accordingly. So you'll have the top board will be zone 1, 2, and 3, and below would be 3, 4, 5, and 6, or however you're going to do that. And then installing the various dampers. Avoid installing the dampers with the motor on the bottom. If condensation forms, it could damage the motor. Ensure the mounting screws do not impede the movement of the damper. I've had that happen to me a few times, and that's always a bear once it's installed. So as you can see here, they're recommending that you mount the motor up on top, not on the bottom. They're recommending 18 gauge or larger thermostat wire. Wire length should not exceed 125 feet between the panel and the damper. And when there are multiple dampers in a zone, combined wire length should not exceed 125 feet in that zone. Label individual zone damper wires at the zone control to prevent mismatching wires. So make sure they're all grouped together per zone. And this is a close-up of the motor itself. As you can see, you've got your common, power open, power closed, and that's going to go to the corresponding zone, whether it's zone 1, 2, 3, 4, 5, or 6. You're going to make sure you're wired to the same thing here. If you miswire those, you will have a problem. If you wire which zone it is, there again, the further you get along, you will end up with some error codes because it will recognize that. It won't tell you what the problem is necessarily, but it'll recognize you have an airflow issue. So as you can see here, this case here, you got 3 zones. 1, 2, 3, power open, power closed, common. And on the bottom here, you can go up to 5 zones. This case here, you're going to daisy chain them all in. 1, 2, 3, and home run it back to this case here is zone 3 or 6 on the panel. So we're going to go over the wiring overview. So the Econet bus, that's going to be your E1, E2, your R and C. Your E1 and E2 is going to be your communication wires. Your R and C is going to be your 24 volts. The board does not have to be wired directly to the main Econet stat. The wires can connect into the Econet bus wiring at any point. So this is going to be a little bit different than your traditional zoning, like Honeywell or Jackson Systems, what have you. It's going to be quite a bit different than that. But once you kind of understand it, it's kind of plug and play, and it'll actually recognize itself. Shielded wiring. So if your thermostat wiring is located near high voltage wiring, cable, TV, Ethernet, or radio frequency equipment, shielded thermostat wiring can be used to reduce or eliminate potential interference. Connecting the grounding shield at one or more locations can cause current loops in the shield, reducing its effectiveness. Shield wire can be connected to the RT terminal at the zone panel or outdoor unit as applicable. There again, we have our Econet bus right here. Unused terminals, RS, RTN, and our IAQ relay, not going to be used. Dip switches, and zone 1, 2, and 3. Okay, in a single, this is your dip switch settings here. In a single board application with or without intelligent bypass, both dip switches must be off. So if you're doing a single board system, the dip switches are off regardless. Very simple. Even if you're using a bypass, which if you're doing a 2-zone system or a 2-board system, you have to turn one of them on for the bypass. But a single board system, both dip switches will be off. Zone 3 bypass is enabled via the Econet smart thermostat and not the dip switch. So here's an example of our 2-zone wiring. We have our 2 zone dampers here, zone 1, zone 2. We're not using a bypass. So we have our outdoor unit here. So we have our 4 wires going here, E1, E2, R and C, going to the furnace. Then we're daisy chaining out of the furnace going to zone 2 or zone 1, whichever it is. You're going into there, so you're going to daisy chain back out of there to zone 1. So that's going to be like zone 1 in this case here is going to be the end of our Econet line here and our outdoor unit here. So at that point, we can tag into our Econet bus on our zoning board at any point on this. Doesn't matter where it is, but we can tag off of here. So E1, E2, R, and C. And then, like I said, the biggest thing is the zoning board can connect anywhere at any point on this network. But it is important. You have your 2 endpoints, and everywhere else has to be daisy chained. So if you're going to do a 3 zone, you got to come in here, 4 wires in, 4 wires out, daisy chain to the end. It is important, which we'll get into a little bit. 2 zone is super simple. You know, it will always recognize the second zone. It's when you get to 3, 4, 5, and 6 zones. If your wiring is not correct, it will not recognize those additional zones. Yeah, bypass for a single board application. There are 2 options for installation of the intelligent bypass. Option 1, the intelligent bypass can be wired to the zone 3 damper output of a single panel. For this installation, the user will also need to enable the intelligent bypass setting from the zone 1 smart thermostat. To get to that, you go to zoning or menu, settings, zoning, intelligent bypass enabled. Then steps for configuring the Z3 to be used for intelligent bypass. Now this is big here. Ensure your Econet smart thermostat has the version SWVER 03.01.26. It's got to be that or after. If it's before that, it may not give you the option to enable the intelligent bypass. So with system installed, ensure zoning is enabled. Menu, settings, zoning, and then note the intelligent bypass should be wired to Z3 on the zone panel. Under zoning settings, enable bypass damper installed. A 1 through 3, zone SW1 settings. In a single board application, the SW1 must be properly set up, and both dip switches will be set in the off position. One board, dip switches are always in the off position. In some instances, you will have to install a secondary transformer. Field supplied transformer may be installed when more than 5 dampers are used or 2 zone panels are used. The 24 volt 40 VA transformer must be phased correctly. Connect the C terminal from the indoor unit to the zone panel, and do not connect the R terminal from the indoor unit to the zone panel. That is important. And I'll show you how that's set up here. So if you're going to use, in this case here, it's a single board. We're using more than 5 dampers, so we're going to add a secondary transformer right here. We're going to power this board up from here, our common and our R. But we're not going to bring the R in from our furnace board to this R, but we will bring our common in. So you'll have your 2 commons on common, and you'll use the additional secondary transformer to power your R. Now, if you're going to do a 2-board wiring with an additional transformer here, you'll see we'll come off our Econet bus, E1, E2, and we're going to jump down from here, E1, E2. We will bring our equipment common in, the brown here, into our common. Now we're going to bring our secondary transformer into the second board. So we're going to go common, and we're going to jump that up to our main board common, and we're going to bring our R to the secondary board. We're going to jump that up to our primary board. That simple. Just don't remember, if you're going to add a secondary transformer, do not bring the equipment R in to the zone board. We'll go over checking the transformer phasing. So measure the voltage between the system R terminal and the external transformer R terminal using an AC voltmeter. If near 0 VAC is measured, the transformers are in phase. If 48 VAC is measured, the external transformer is out of phase. Swap the transformer's wiring to correct the phasing. So it shows you right here using your furnace board, R terminal, and then you're going to come down here to your zone board, the R terminal. So ideally you want to read 0 VAC. If you do, transformer's fine. If you read 48 VAC, the external transformer is out of phase. Now here we'll get through to zones 4 through 6 with no bypass. So you have zone 1, 2, 3, down here 4, 5, and 6. So if we're going to do 4 zones, 4 to 6 zones, no bypass, SW1. So our boards 1 through 3, there again, our dip switches will be off. If we go down to board 2, 4 through 6, we want to turn dip switch 1 on. We don't have a bypass, but we are using zones 4 through 6. So dip switch 1 on. Now there again, bear in mind, if you're going to make these changes on dip switches, it has to be turned off when you change it, and then turned back on. So the board will accept the dip switch change. If you change it on the fly when it's powered up, the board will not accept the dip switch change. And if it doesn't accept the dip switch change, you will get some erratic operation. So here we go, Econet 6 zones, no bypass example. So we got our dampers 1 through 6. We're at the end of our chain. We have our outdoor unit, so we're going to go 4 wires in, RC, E1, E2, into the furnace board, daisy chain out of the furnace board. In this case here, doesn't really matter what configuration these are staggered in, but you're going to go in 1 zone stat, 4 wires in, 4 wires out. Daisy chain to the next zone stat, 4 wires in, 4 wires out. You're going to daisy chain from one to the other till you hit the end of the line. In this case here, they're using the example zone 1. So now we have all zones 1 through 6, our primary control, and our 5 zone stats. They're all on the exact same bus. And then anywhere in this line here, we can come in and tag in our E1 and E2 to the Econet bus on zone board 1. Now, if we're going to do a 2-board system, a 4 through 5 zone with a bypass, now here's where it gets kind of important again. Once again, zone 1 board, our dip switches are going to remain off in both cases. Now, since we're going to use zones 4 through 6 with a bypass, we not only have to turn on 1, which indicates we're going to use zones 4 through 6, but we're also going to turn on dip switch 2, which is going to indicate we're using a bypass. And then bypass will be used on number 6. This is equipment transformer R terminal. Caution, when a secondary transformer is added, do not connect the equipment's transformer red wire 24 volts to the zoning panel. So this gives you a kind of a color thing here. So we have all of our thermostats, primary and zone stats on the Econet bus. We're going to come over here and go E1, E2, R, and C. As we go over to the zone panel 1, we're going to have E1, E2, common. We're not going to bring that R over here because we're using a secondary transformer. So now we have all the zone dampers in. Everything's wired up. Dip switch is set. We're going to start up and commission the system. The startup and commissioning overview. This process should be performed in the following order. You will have an automatic filter check. Ensure zoning is enabled. Reassign zone ID assignment at each zone control. Perform a zoning checkout, full duct measurement, and linearize the dampers. At that point, you can fine-tune the adjust the airflow as needed. And additional setting status. You can name zones, view the zone statuses as well. Startup and commissioning can take up to an hour depending on how many zones the system has. So be sure to leave plenty of time in your schedule for this process. Once it starts, you just have to let it go. If it's not set up correctly, obviously it's not going to work right. So don't rush the zoning setup once you have it set up. Upon power up of the initial installation, you need to select the filter type. Are you using a media, electronic air cleaner, or an EAC with media? The filter check. Upon initial power up, the system will power open all dampers if it's zoned and turn blower up to roughly 2/3 of cooling CFM and measure static as a baseline. The system is looking for changes from the static baseline. Changes typically include dirty filters or other obstructions, people shutting registers, blocking returns, you name it. Any changes from this will trigger an alert. Down the road, once it's installed and set up, if there's any kind of major changes, you're going to get a replace filter alert. The system will perform a scheduled filter check every day at 9 a.m. So every day at 9 a.m., it's going to start up, do its quick filter check, and if it detects a problem, it's going to trigger you an alert. You can adjust the schedule by going into the menu, settings, installer, thermostat, and then you can actually change the filter check hour time. Once you get into the menu, go to settings. From there, you'll go to zoning. So if you want to enable the zoning, you would highlight this and turn that on. So this field must be enabled in order for zoning to run. Ensure this is turned on before proceeding with zoning checkout. If this is turned off, all dampers are open and the system operates like a single zone system. All zones follow number 1. This setting from zone 1 is copied from the Econet smart thermostat to all the zones. This basically locks out the ability to make adjustments from other zones and zone controls. They just become room sensors, basically. and they follow Zone 1 settings. Note that the zone control sensors continue to monitor and maintain room temperatures. So I can't think of a lot of applications where you'd want all your zones to follow Zone 1. Otherwise, there'd be no need for zoning. So your humidity sensor, your default's going to be Zone 1. That's going to be your main zone. So you can use the sensors to use Zone 2, 3, 4, 5, 6, or you can average all zones. These options only appear if the zones are detected. You do have the ability to overcondition. So no overconditioning or 1 to 10 degrees. Do not confuse overconditioning with overcooling. Overcooling is strictly a dehumidification function that allows the system to remove latent heat from the space. Overconditioning, the zoning function, is used for dumping excess air from other small zones. If the system's minimum capacity is greater than the smaller zone calling, there needs to be a place where it can send that excess minimum air. This setting tells the system how much difference from the zone temperature is allowed before the next zone will need to start absorbing the excess air. So if you've got multiple zones, you can start dumping a little bit of air in each zone to prevent static pressure issues and faults. If you have a bypass damper in there, then that kind of takes that out of the equation. If there isn't a bypass damper, the overconditioning should be set at least 1 or 2. If the field is set to none, airflow limits and capacity limits might prevent the system from conditioning the calling zone. So they're recommending you at least put 1 or 2 under the overconditioning option. So your zone airflow setting, this affects noise reduction. The airflow select setting, you have unlimited, high, medium, low, low. CFM values will populate after the duct measurement test is performed. Each zone comes with a default zone ID as Zone 2. So if you've got 6 zones, Zone 1 is going to be your master zone. Every other one will come up as Zone 2. Zone ID assignments must be updated at each zone control, not the smart thermostat. So if you go to whatever zone you're going to next, you have to go in there and physically change that and set your zone assignment up in the zone stat. If these fields are not updated, the system only shows 2 zones in the status screen. So they're going to operate as a 2-zone system. The information that displays will randomly be selected from the various zones with the same ID. Each zone sends out information every 8 to 10 seconds. So the information could appear random. This assignment is shown in the upper right-hand corner of the zone control display screen. This is going to be your zone control here. Zone name, brand, zone ID. So you can say Zone 2. You can name this whatever, bedroom 2, bedroom 3, master. So you're going to set up your ID assignment here. Settings this is in the zone control. Settings basic. Remember to set this at each zone control, as all zone controls are defaulted for Zone 2. So you go down here to Zone ID assignment, and you can change this Zone 3, 4, 5, whatever it is. This gets into the duct measurement. During the duct measurement part of the commissioning. The system will start the fan at low speed and open each zone one at a time. This will establish and assign each duct area a percentage of the full system, including leakage. Duct measurements takes about 1 minute per zone. Most alarms will not affect duct measurement or linearization. Only blower alarms or communication alarms will stop the tests. Now, we'll tell you, like we used to do some regular zoning years ago, and sometimes you'd have some really small zones, like a 4, a 6, or whatever, and you didn't really need to incorporate that because it was, doing whatever room, and it didn't matter. But when you're setting up the duct system on here, you got to make sure the entire duct or all the runs are, under some sort of zone control. If you have any unzoned ducts that are still flowing air, it will eventually cause you alarms because it will recognize that as duct leakage. It'll still run the system and it'll be fine, but you will get some odd cooling operation, usually on one zone, and some alarms. So all ducts, all runs have to be zoned in some fashion. So you're not just, free flowing air, because it will pick it up and it will let you know that. Okay, so it's time to start the duct measurement part of the zoning checkout. We'll go into the service, zoning checkout. Now here we have the options. So we're in service here. If you want to check out just your furnace by itself in the future, click on furnace checkout. If you have an inverter system and you want to check it out in high cool or high heat, go in here and do that as well. Here, your zoning checkout. Click that. We do want to do a zoning test, so we can turn that on. To start the checkout, tap off, and then use the arrows to toggle over duct measurement. So we'll go ahead and start test. So in this case here, we have a 2-zone system. It's saying each zone is good for 50%. On initial power up, the duct measurement will show equal percentages for both zones. Status. This is the countdown, number of seconds from 60. So it's actually doing a countdown. And opening zones, when you initialize the duct measurement test, the air handler will open all the dampers to run at a predetermined CFM. The system will establish a baseline, static, and airflow. Closing zones. Note that the status has moved from opening zones to closing zones. If a bypass is installed, that will always be the final zone opened before the process to close zones begins. After 60 seconds, the test will complete and each zone's percentage will display. In this case here, we're saying zone 1 can handle up to 49%, whereas zone 2 is a little smaller. It can only handle 46%. Okay, so at that point, we're going to go on to the linearization of the dampers section. So we're going to go to linearization. During the linearization process, the system's fan will run and operate at various speeds. The dampers positions at each zone to establish new airflow curves. This will optimize the damper position to the various airflows using proprietary algorithms for optimum efficiency and comfort. Linearization is performed only once upon system startup. One exception: if you're replacing the Econet smart thermostat, the linearization test will need to be run again. And this process can take up to 5 minutes per zone to complete. Linearization graph. So your zone dampers are typically non-linear with respect to the delivered CFM versus the damper position. So whether it's a square, round position. Okay, so we're going to do a checkout here. Zone 1, Zone 2, Zone 6. Now it's time to fine tune the zoning settings. So if you want to really fine tune the system, zone airflow values are set at the maximum airflow allowed at each zone. So some of the fine tunings are used for sound, sets airflow maximum for each zone to prevent excess noise, can limit system operation. If only one zone calls, its maximum airflow must be more than the system minimum CFM or the equipment will not operate. If you run into a situation where that's what's going on, you'll generate a T003Z alert history. An example, if a zone was set to medium low, which showed the airflow system at 469 CFM, however, the system had a minimum capacity of 506 CFM, the system will not be able to initiate a call for heat or cooling because the airflow is too low. And in return, you will get a T003Z alert. You have your zone demand and damper positioning. Demand for each zone is as follows. Largest zone demand drives the equipment. Any zone demand greater than or less than 0.5 degrees will turn on the equipment. All zone demands then must be greater than or less than 0.25 to turn off equipment. And then the dampers are positioned accordingly to the following rules. Any zone demand greater than or less than 0.5 degrees is fully open. The zone with largest demand will be fully open. All other zones with demand are positioned on distance from full open to off demand 0.25 degrees. The zones with demand are 0.25 closed. And if you actually watch the dampers, I mean, during the operation, you can actually watch them open and close ever so slightly. When airflow adjustments are made, consider the following: zone sizes, presence of a bypass damper, zone airflow meets equipment capacity, the minimum and the maximum, and your zone overconditioning setting. We spoke about that earlier. If there is not a bypass damper, see the excess airflow control in zoned application section. That's where you want to put that on 1 or 2. Systems with smaller zones than the minimum capacity of the system may require a bypass to allow the system to dump excess air while meeting the demand of a small zone. And that can be achieved with 2 ways. One, it can use the overconditioning feature to where it's going to dump off additional air, or you can use the bypass. Adjust the zoning settings. We have our settings button here. Go to the zoning. And here we can kind of dial these in a little more. So we have our unlimited high, medium, medium, low, and low. In this case here, zone 1 was set for medium high at 985 CFM. And our zone 2 was set at medium high at 1081. Default names. So you'll have your default names are zone 1, zone 2, etc. Don't confuse the zone name with the zone ID. Zone ID assignments must be set up for all connected zones to appear on this screen. So you can have your zone ID as 1, 2, 3, 4, 5, 6, but you can name your zones whatever you want to. Kitchen, dining room, master bedroom, basement. Names appear in the following locations. In the zone status, and then also the zone control, bottom right-hand corner of the main screen. So if it's set up correctly, as you go into, we'll say it's a basement. If you look there, it'll say zone 1 through 6. It will be your ID, and then you can name it. You can say basement. So here we go, zone 1 name text. You can change it from zone 1 or zone 2. After setting airflow and renaming zones, it's time to check out the zone status. So we're going to go in here. The zoning status screen. This is only viewable from the Econet smart thermostat, the primary zone 1 thermostat, not the zone controls. In the status screen, it shows the following for all zones: heating, cooling, set points, actual temperature, relative humidity percentages, percentage damper open, also your CFM and airflow. The system's mode affects the first columns 1 and 2. Auto mode will show both heating and cooling. Cooling mode will show only cooling set points. Therefore, heating mode will show only heating. You also have fan only, emergency, and off modes. Now the status is pretty handy with any communicating system, because it will give you an in-depth bird's eye view as to what's going on inside the system as it's running. So if you go into the status, in this case here, you can go to zoning, and it'll tell you. The system's in cooling mode, we know that. Systems mode affects the first columns 1 and 2. So we know it's in cooling. Downstairs, our cooling set at 68. Upstairs is set for 73. We see the relative humidity set is 66% in the downstairs, 67 upstairs. Damper open, 100%. Downstairs, 57 upstairs. And our CFM is 800 downstairs, 732 upstairs. If we had a bypass damper, it would also show that. This time we're in auto mode. We see heat and cool. So those are heating set points, cooling, relative humidity, damper, CFM. Okay, so once you get that all set up, you've got the dampers in, you've got everything wired up, all your zones, IDs changed, named, you have your duct test, the duct linearization, you've done your fine tuning, so everything should be working okay. Now we'll get into some of the diagnostics and troubleshooting. So we'll go over some LEDs here on the board. Okay, the first one, top one here is LED transmit and receive. Random blinking indicates serial bus communication. This LED here tells you your green board is powered, flashes 1 second increments. The flashing red or amber is not a fault. This can happen when a lot of data is being passed through the board. Come down to the LED here. This is unused. Okay, so this is going to be pretty much the same all through here. Okay, so if it's solid green, your dampers are open. If it's flashing green, your dampers are opening. If it's flashing red, your dampers are closing. If it's solid red, your dampers are closed. And if it's off, the dampers are partially open. Okay, you have a blinking asterisk. Airflow limit too low. So you have a blinking asterisk next to your zone's airflow settings. So if you're saying your airflow limit is too low, some causes of this is the airflow minimum is set too low for that zone. For one, the asterisk is flashing next to the affected zone that's having the issue. So whichever zone it's flashing next to, the system doesn't respond to the zone demand. The system might still be able to respond to the demand if it can dump air into other setback zones to fulfill the minimum airflow required, or it can dump air into the bypass to fulfill the minimum airflow required. Possible resolutions, change the airflow setting for that zone. Easy enough. You can increase the overconditioning. In some cases, you have to add a bypass. Big one too is verify if filters are clean. That can cause it. Or you may have to correct the ductwork. Zone control damper overcurrent faults. You'll get these faults on the Econet. In this case here, you have an A007Z, zone control damper overcurrent, fault 1, A008Z, zone control damper overcurrent, fault 2. Some descriptions and causes: you could have a jammed damper, shorted or defective damper, or you could have wires to the damper that were shorted. And so if you get something in there obstructing it, you will get this fault. So possible resolutions: remove any obstructions from the damper, and then double check your damper wiring. This one's zone control bypass dip switch error, A009. So some descriptions or causes here: bypass dip switch on zone panel 1 is set. Bypass will not function. So if you're using one board and you have your dip switches turned on for whatever reason, you will get this fault code. Possible resolutions: set bypass switch on zone panel 1 to off. If bypass is desired, set bypass switch on zone panel 2 to on. Zone control communication error. So depending on which one you're looking at here. So if you got if your third zone's communication error, A011Z, zone 3 communication error, could be 4, 5, and 6. Some possible causes: zone control isn't connected. Zone control isn't wired correctly. So if you cross up your E1 and E2, that will certainly cause a communication error. If you have a problem with your thermostat wire, and then accidentally adding a zone that does not exist by changing the ID of an existing zone to something else, that can also get a initiated communication error. Some possible resolutions: properly reconnect your zone control. Ensure the proper wiring was used was 18 gauge. Fix wiring connections. Replace thermostat wire. Replace thermostat. Reset the defaults on the master stat. Note if you do reset the faults, this will remove all of the system settings previously established. So if you do reset to factory defaults, you have to go all the way through your duct test and your linearization test as well. Some other damper faults here, zone 1 through 6. We'll pick 3A017Z, zone 3 damper fault. Some possible causes: one or all the dampers in a zone are not wired correctly. One could be a damper is wired incorrectly or not wired at all. We had one where that was the case. For whatever reason, it was wired on the board, but it wasn't wired at the one damper, and this is the fault they got. So possible resolutions: correct damper wiring. Zone 1 through 3 panel communication error. A022Z, zone 1 through 3 panel communication error. The description and cause: zone panel 1 was detected and now it's not communicating. So in a case like that, you want to check all your wires and power to that zone panel. Zone 4 through 6 communication error, same thing. Some other causes: zone 2 was detected, now it's not communicating, or you could have an incorrect SW1 dip switch setting. Resolutions: check wire and power to the zone panel, and then check your SW1 dip switch to ensure you have the correct setting. So in this case here, if you have a second panel for your 4 through 6 and you don't turn on dip switch 1, you very well could end up with this exact communication error. This is for your zone airflow alert. It caused the shutdown. So it gives us 6 zones to choose from here. So we'll pick zone 3, T003Z, zone 3, airflow alert, caused shutdown. The description or cause: the system is shutting down because the airflow limit for that zone has not been reached, or has been reached. So possible resolutions: ensure zones and ducting are realistic. Either increase the airflow limit for the zone, adjust the overconditioning setting to a higher number. Both settings are found in the main thermostat and menu settings and zone settings. So you got to make sure, one, that your duct can truly handle that. A lot of times you'll catch some of this before you get to this point, and usually in the setup. But it's telling you that you've reached the airflow limit for that zone. So you need more. You need to relieve some pressure. You need more duct. More duct or less airflow. This is a big one. Blower cutback caused shutdown. T007Z, blower cutback has caused shutdown. The cause description: the system has tried to run the blower at the required blower speed, but the duct restriction prevented adequate operation. You'll get this same cutback on other communicating systems, the furnaces and the air handlers. It'll say most of those are 66. If you're getting a blower cutback situation, that means your static pressure is exceptionally high and the motor recognizes that it can't run at its required blower speed because of the restriction. Possible resolution: if a zone airflow limit is set to unlimited, you can apply airflow limits to that. Menu settings, zoning. Another thing is check for possible dirty filter. That will cause it. If you have somebody that's shutting vents down, shutting supply registers down, or blocking returns, that will also cause the same thing. And you can actually verify your static pressure by going on your main thermostat, going to service, and then status, and then going to your air unit, whether it's furnace or air handler. Go to your furnace or air handler. On the left hand, 4 down, it will tell you what your static pressure is. These systems, as with all ECMs, they do not want to exceed 1 inch of static pressure. So if you look there and you see 1.25, okay, you know you have some static pressure issues. Your duct's too small, either on the supply or the return. If you look on there and it says unlimited or unknown, that means it's so far out of whack that the blower cannot even determine what the static pressure is. If you do indeed have that, then you have to dig into your duct system and find the culprit, whether it's supply or return, and get that resolved. Now here's a good one: excess duct leakage detected. T008Z, excessive duct leakage. I mentioned this before, so if you've got, well, let's just say you got everything ducted, but you've got a mud room or something off to the side that you don't really care about zoning that. It's not a big deal, so you just don't zone it. You just leave those free flowing. This system here will recognize that you have, in this case here, massive amounts of duct leakage, because not every duct is zoned, and you will get this code. So in this case here, more than 25% of the system airflow is leaking before the dampers. Check for unattached ductwork or ductwork that has no dampers. System will operate normally with this alert, but a lot of times you can get some slightly erratic operation. We saw one that did that. But so make sure all your ductwork has dampers in it, and that will prevent this excess leakage fault. Here's your supply temp exceeded to bypass. The T027Z supply temperature limit exceeded to bypass. Description or causes: if the leaving air temperature is exceeded while bypassing, the bypass function is terminated. The system could shut off if dumping into the other zones is not possible. So the following limits have been exceeded: the furnace, 160 degrees, heat pump with electric heat running, 135, heat pump alone, 120, or cooling mode, 45. Possible resolutions: ensure proper airflow setup and bypass settings. If error happens with furnace, where the limit is 160, but the limit can be adjusted in the furnace settings. Consider moving the supply air sensor to within 6 to 12 inches, moving it between 6 and 12 inches. Okay. That is pretty much it for the Econet zoning presentation from Rheem. Once you do one or two, it's fairly simple. If you're 2 and 3 zones are relatively simple, because you can get away with 1 board. As you start going into the 2 boards, up to 6 zones, it's a little more intimidating, but it's not quite the end of the world. But it's a little different. But it's designed for comfort, specifically to work with the variable speed and inverter products. I did some of these years ago with Bryant, and then we actually did a lot with the trains. We had really good luck with them. And from what I've seen with the Rheems, same process. Main thing is get your ductwork right ahead of time, so you're not having to go back later and correct all that. But if you're interested or have any more questions in regards to the Rheem zoning or the Econet, please feel free to give me a call anytime. There again, do appreciate you taking the time to watch this, And if you have any questions or anything, please let me know. Thank you. Y'all have a good day.